Hi everyone, welcome to Weeklywed from Business School of AI. Weeklywed is our happy place to share, learn, discuss, and explore. Weeklywed occurs every Wednesday at 9 a.m. Pacific time. I'm your host Yashaswini Vishwanath, and you can call me Yash. I'm logging from Bangalore, and I would like to know where you're all from. We would like to get to know you better. Please type away your name and where you're logging from in the chat so that we can connect with you. I'm an AI researcher who focuses on responsible AI, and I'm pursuing my master's in AI here in Bangalore. And I have over 10 years of experience in the IT industry. And so at Weeklywed, we empower and enable the audience to break into AI and to explore more of it. Generally, we host speakers from varied backgrounds working on AI and allied technologies. Today is a very special session for two reasons. The first one is that we have a research paper readout, which was recently published in Journal of AI, Robotics, and Workplace Automation. And we have Chinmayi Ramasubramanian, who will be joining us for the second half. And I would like to introduce Chinmayi now. Chinmayi Ramasubramaniam is a student of class 10 in Sri Kumaran's Children's Home, Bangalore, India. She is deeply interested in research and innovations and has done research in applications of machine learning in different fields, especially bioacoustics. In 2021, her research on diagnosing stages of COVID-19 using machine learning won an international award at International Science and Engineering Fair 2021. In April 2022, her research on averting human-elephant conflict was selected as Grand Award winner by the IRIS National Fair conducted by India. Her project was selected to be represented at ISEF 2020 at Atlanta, USA, and has won second Grand Award and Special Award by Acoustical Society of America and USAID Science for Development. Welcome, Chinmayi. And now I will go over the research paper readout that we got published at Journal for AI, Robotics, and Workplace Automation. Post that, Chinmayi will be talking to us about AI for elephants. And now it is AI for autonomous vehicles. Welcome, everybody. Welcome to Weeklywed. And here we go. I will share my screen and so, this is Henry Stewart Publications, the publication in which Journal for AI, Robotics, and Workplace Automation was brought by. And this is the website. So I'll put the link here in the chat. So Journal of AI, Robotics, and Workplace Automation is a major new professional and academic journal for all those involved in researching and applying artificial intelligence and related, often complementary techniques or technologies for automating tasks and processes within organizations. So this is the, here we can see the different kind of articles and the key topics that they call for. And our article, our research paper is in volume 1, number 3, spring 2022. This is where you can access the abstract. The abstract Inclusive Ethical AI in Human-Computer Interaction in Autonomous Vehicles. This is the abstract here. So first of all, I would like to give a very brief introduction of the paper that we are trying to discuss today. So this paper was mentored by Sudha Jamthe, authored by Sudha Jamthe, and then co-authored by me and Suresh. So we all know about autonomous vehicles. We have seen in the previous sessions the different levels of autonomy and how important it is for an autonomous vehicle to be able to see what is there on the road. Many papers have been written about what the autonomous vehicle has to see on the road. This paper specifically talks about the AI in the car, the computer vision in the car, that is when it sees the driver. So here the main concept that we have to know is about incidents. When an autonomous vehicle is on its own and is driving on the road, in case it has to halt, in case it has to brake, say there is a human there or there is a property, then it has to, we call it an incident, it has to give the agency, it has to give the control to the human such that the human will be able to take action. In this case, when it has to do this, it has to recognize the human that is there. So generally, the software piece that does this is called ADAS and DMS, driver monitoring system and ADAS. So these two together, they enable the autonomous vehicle to be able to navigate on the road with the human there. The problem here is when the computer vision algorithm that is running here cannot detect the human there, although the human is there. What are the scenarios in which such a thing is possible? It is possible when the AI algorithm that is running there in the computer vision module is not trained to detect a person that is there. So in order to give an example of this, here is the fair face data set that we have. If we see here, we have the different kinds of faces, different skin tones, different ethnicities, age, gender, race. So this is a balanced data set, fair face data set. Now let us assume there is an autonomous vehicle computer vision which is running on this, and it cannot detect the human, that is, it cannot detect the face that the human is sitting there. It has to look for alertness. Eyes open, eyes closed, that is what it has to see. But in order to see eyes open, eyes closed, first it has to detect the face. So here we see that a balanced data set like fair face will have a balanced number of photos, images of people of different ethnicity, age, gender, and race. Now, going back to the research paper, this is a fair face data set that is there. They have provided the model as well as the data set. I would like to show the paper itself. Just a second. So as we are going through this research paper, There are two things here. One is the research that we have done, the content of the research as such. Secondly, the method we have used, the research methodology, the experiment design. How did we go about doing this research? That is the main key takeaway from this session. The paper is available on Henry Publications. Anybody can go through it, read it. And we have the main way in which a research paper has to be written is that it should be all encompassing. When we take a research paper, it should have the complete story within itself. So the main key takeaway from this session of Weeklywed is we would like to tell you how we went about doing this research, how we did the experiment design. So first of all, conduction of the research and then reporting of the research are two separate things. The reason why we highlight this is report writing is as important as conduction of the experiment. First we have the ideation phase, the problem statement phase, then we have the experiment design, then we conduct the experiment, we get the results, we analyze the results, come up with conclusions, and then we do the report writing. In the process of all these things, we would have done a lot of literature review. So now, how this research paper is structured is very important because research papers are universal. All over the world, people have a certain format and everybody has to conform to that. It is a scientific writing. There is a particular language to be used and a way it has to be written so that it is universal. Anybody from any part of the world will be able to pick a research paper and they'll be able to read it as easily as any research paper that is there around them. So first of all, we have the title. So it is Inclusive Ethical AI in Human-Computer Interaction in Autonomous Vehicles. The crux of this paper is inclusive AI. We are trying to make AI inclusive, to consider everybody. So this is one of the spoke of responsible AI. We want any AI that is out there in the world to treat everyone equally and to consider everyone equally during the design phase itself. By showing this research, we show that there is a bias and we call for bias mitigation. So here we talk about the human-computer interaction in autonomous vehicles. So by human-computer interaction in autonomous vehicle, we are referring to the ability of the autonomous vehicle to give the control to the human when there is a potential incident on the road. Now we have the abstract. Abstract, all in all, tells what the paper is about. The way the abstract is generally written is we first write a skeleton of the abstract, we write the paper. As the paper is evolving, we keep refining the abstract. And at the last stage, we rewrite the abstract again in such a way that it takes in all the experimental results that we have done. First of all, abstract tells the story. It tells why we have chosen this problem. Why is this problem important? Why should we even do the experiment on it? And what are the experiments that we are designing? And what conclusion are we trying to get from this? Then we have the keywords. Keywords will be the technology that is related to the paper. Why we need very good keywords? This paper will get indexed in Google Scholar. In that case, people search for keywords. So when we give keywords like this, it will be beneficial for others to build upon our research so that they'll be able to search for it easier and build upon. So here, if you see here, there are this in fine print, we have these things. These are called citations. So here we have used the Fairface data set. We have used the Fairface data set. So we have cited the Fairface data set, and the other paper that we have seen, we are citing it. And then is the introduction. Introduction is where we start telling the story. We start telling the domain, what is there around, what is already existing. So here we talk about AI, what is autonomous vehicles? We talk about the autonomy in autonomous vehicles. We say, what is the AI in the car? Here we're talking about the ADAS, advanced driver assistance systems, and we're talking about the DMS. So here we refer to that. What is ADAS? We are talking about it. And
Yash,
then,
Yash, if you
yes,
don't mind, are you going to walk over how the paper is built? Are you also going to tell us what is the abstract and what is the paper? Are we doing a readout?
yes, yes.
No, I didn't want to interrupt your flow. I was just curious whether you were pointing at abstract. I was curious whether you were going to tell us what is the abstract, because everybody might not be familiar with autonomous vehicles and ADAS and what this paper is about. It's a peer-reviewed journal, right? So there's a lot more rigor that went into it.
Okay, okay.
Now, was that your plan? I didn't mean to interrupt it.
I will just quickly go over this, and then, or what I can do is I can go if like breakfast, I can
Yeah.
tell in detail about this. So first of all, I would like to dive deep into the abstract here. So we talk about driver alertness. We talk about autonomous vehicles. Autonomous vehicles are those vehicles which have a computer vision component in them. There are different levels of autonomy, and based on the level of autonomy, an autonomous vehicle drives by itself. There could be levels of autonomy where it is trying to get the human assistance. In this case, we are trying to look at driver alertness. When we talk about driver alertness, the ADAS system should be able to detect whether the driver is alert or not. When an autonomous vehicle is going over the street, it should be able to see whether there is any incident, is there any problem? And if there is any problem, it has to immediately give the control to the human, but first by checking whether the driver is alert. It is important that this AI be inclusive without bias, because treating drivers differently will impact the safety of humans, not only in the vehicle, but also on the road. This paper evaluates the AI that powers driver attention systems in the car to check if the AI treats all humans inclusively the same way beyond their ethnicity, gender, age. Does it follow AI ethics principles of trust, transparency, and fairness? Driver attention is built using two different models. One uses camera data to recognize humans. The other evaluates whether the human is alert. So we saw that both the models are biased and not inclusive of all people in the situations. Also, we saw there are some unethical practices in how humans are tracked to check for alertness by using infrared sensors that track the retina movement without a consent of privacy. So we saw this tech where in the car mirror there was a camera that was placed, and it used to track people's eye retina movements to check for alertness. This was done without privacy considerations. We also present in this paper results about how the car is biased against some human in its face identification, how the assertion of alertness of humans to hand over control, how is it flawed because of the definition of alertness itself? And at the end, we recommend some mitigation techniques and we call for research. So this is a peer-reviewed, double-blinded, peer-reviewed research paper. So what we mean by double-blinded peer review is when we do all the research and when we submit it to the board, they will not know from whom the research has come, who has done the research. They just know that some scientist has done this. And the person who will be reviewing it too will not know who is reviewing it. The person who is reviewing it too, even their details are not given to us, the authors. The authors do not know the reviewers do not know the authors. And that is why it is called double-blinded peer-reviewed. It's a peer-reviewed journal because it is evaluated by peers who are good in their topics and who have the experience and the exposure. It is even you can be a reviewer. Anybody here can be a reviewer and review some of the conference papers. That's a whole different thread which we will take later. But as I said, this is a peer-reviewed, double-blinded research paper. So I hope you got the crux of the paper. Here we are talking about alertness. We are talking about the face identification. We are talking about the alertness construct itself. So first of all, we talk about the AI in AV. There are many AI that is there in AV. The AI that is most crucial is the one that is actually doing the driving and giving the control to the human in case of an incident. Here we consider the face recognition system, face detection system. So autonomous vehicles have sensors, radars, lidars, cameras. So sensor fusion is a technique to combine the data from these sensors to help the vehicle get a mental map of its surroundings. This shows the roads, lanes, sidewalks, other cars, people, and all of that. So the AI collects this information and it develops the perception for the car to do path planning to decide to stop, move, or make a turn. This is the foundation of autonomous vehicles. So here we see that we have ADAS, which is Advanced Driver Assistance Systems. So what ADAS does is it actually helps. So we call it driver assistance system. It helps the driver. So if the driver is feeling drowsy, it alerts the driver. So that is some of the things that it does. It mainly tracks the driver and it helps the driver. Here, based on the ADAS, forward collision ADAS feature, it uses proximity sensors to check if the car is getting too close to the vehicle in front of it. Then the AI decides to alert the driver or turn on adaptive cruise control to automatically reduce the speed of the vehicle to avoid collision. And there is no transparency about the AI that powers these decisions inside the vehicle. So we will look at it more through the research paper. So once we talked about AV, we went into the AI in AV. In AI and AV, we covered what is ADAS, and we talk about levels of autonomy. We saw that in a recent Weeklywed session also. So we have level 5, which is full autonomy. Vehicle can drive without human support in all road conditions. Level 4 is to drive autonomously, but within a specific set of roads. And we have level 2, level 3 ADAS features given by OEMs. And level 3 is when a human driver is required to be on standby to take control when needed. So here we see the different levels of autonomy. Now, when we come to the crux of the paper, that is the roles of the humans in the car and the agency of the vehicle. Here we talk about different features such as the forward collision warning, lane departure warning, but we focus on the most important thing, that is incident. Here we focus on what is AI ethics and what is, okay, is there any question? Okay. What is AI ethics and what is inclusive AI? So AI ethics, when we talk about AI ethics, so we all know about ethics, right? Those are the moral values that we live with in the society. AI ethics is how an AI can imbibe these tenets of fairness, trust, transparency, and provide a service to the human by following these tenets. So when we talk about AI ethics, we have the term we talk about, that is bias, data bias. So data bias, there are different kinds of biases. Among them, data bias makes the AI biased against some segment of the users. Algorithmic bias is when the algorithm makes decisions that are biased against certain segment of users. So here, when we talk about bias, the bias mitigation techniques are those which will enable us to reduce the problem, have an AI which is fair to everybody and works. So here we have this a beautiful diagram here. The human biases in data. So we have the training data, how it is collected and annotated. These are the human biases that can creep in. Reporting bias, selection bias, overgeneralization. We have many such biases here. And in collection also, sampling error, non-sampling error, insensitivity to sample size. So this we have taken from data bias from Susanna Rath's Inclusive AI Masterclass. So you can go over the YouTube channel. We have Susanna Rath's Masterclass and the pre-class and all those videos there, which will talk about AI ethics. You can go over that in detail. Here we are focusing on inclusive AI. So inclusive AI is where we want to consider everybody when an AI system is designed. An AI system should consider everybody equally and fairly, and it should not leave out someone. In the process of leaving out, it might harm. It might harm that person whom it is leaving out. In this case, it is also harming the people on the street, whoever that may be. So we want to bring in that inclusive AI concept here and try to show that there is a lack of inclusivity in the face detection algorithms that are there. So I will go over that, how we have done the experiment design. So here we try to, we use the Fairface data set and we look at the diverse set of faces that are there and how much we could detect. So if you see here, white female, 9% was detected. Indian male, only 7.39% was detected. Like this, we go over different races, different genders, and we look at the percentages of how it was detected. In order to do this, we use Amazon, Microsoft Face++, and IBM face detection algorithms. So this is already done by Fairface. We have done using Google Cloud Vision. And here, this is a very important table. So the results, whatever we found out during the experiment, we have put in form of a table. So when we talk about the face detection, we have a confidence level. For different confidence level, the percentages of faces detected are different. So when the face is detected, the control is given. Here we see that for 90%, if it is 36.3, for 60%, it will be 95.7. There is a difference based on the race and the threshold. So what we propose is we have a slider control for this threshold such that people will be able to set the threshold. They have the agency to set the threshold. Here we are trying to see that there is it's called an elbow graph because it elbows out. It's like a bent curve and it elbows out and it converges here. So at around 60, we say that that's the optimal confidence. And if we keep that, most of the faces are detected. So the same thing we do for women. We see how it is getting detected for different rays and for different thresholds. The similar elbow graph is seen for that, and we see that there is a 70 as the threshold there. Then whatever findings we have from the experiments, we populate it here and we give it for the open society for them to know that this is the bias that is there. Now we are showing, we are calling it out and we are showing, we are proving. So that's the correct word. We are proving that there is bias. Now it is up to the OEM manufacturers, the car manufacturers to look at this research and mitigate the bias. So here we talk about the different recommendations that we have. We talk about how we need to give a point of inflection and how we need to take the threshold. We also look at the alert construct definition. We say that that construct itself is flawed with limited definition of alertness. And we suggest an AV phase data set here. I'll increase the, okay. So here if we see, we are augmenting the data set with crying, yawning, sneezing. We have tried to capture different faces which have been doing these actions. So even these are alert. So when somebody is sneezing also they're alert. When somebody is crying also they're alert. So earlier alert was just eye open, eye closed. We are telling it has to be more. It has to be augmented. And we have considered this, we have come up with this AV phase data set. And then we try to show that. What is cloud Google Cloud Vision API? How many are detected? This is the confidence thresholds, and this is the API that we are using for sneezing. What it is? So what we see here is it is not able to detect. So there is some problem. It is not able to tell that it is alert. So here we show some. It identified as a dog lying on its back. This particular photo was identified as a dog lying on its back. And there was a cultural sensitivity to women hiding their face when crying. So it failed to recognize that has a human face. So here we are showing about the eyes open. So now everybody is telling eyes open means alert. So we try to say with that confidence how they are faring, how AV face is faring. We use the Amazon Recognition API. And we look at the fair face data set with the same eyes open detection. So we see that 80% of the people are considered to be not alert, and the AV will not give control in an emergency situation when they're either crying or sneezing or crying, sneezing, and the other one was, I just missed it, yawning. Yeah, crying, sneezing, and yawning. So it will not be able to detect it. We say that the construct by itself have to be extended and inclusive. And after we publish all the research and all of it, we call for collaboration for others to work on this research. We say we need to improve the construct of alertness. And we talk about the AI failing to detect different faces, like beard faces, faces with glasses, faces wearing masks, and all of that. So then we give the conclusion where we have the recommendations on how we can mitigate the bias. So basically in the conclusion, we wrap the entire thing again. We tell where we started from, what we did, and what is our recommendation. Our recommendation is to make the face detection transparent and trustworthy by reducing bias and expanding the alertness construct beyond eyes being open. But more importantly, go beyond the algorithm in creating human-centered design inside the vehicle. Also, the main point in this paper is today the machine has agency to decide when and who to give control to humans in the vehicle. And the AI is not being inclusive. The ethical not being inclusive affects the humans in the vehicle and also harms people and property on the road. So our recommendation is to change the design to give agency to the human to take control by itself rather than the AI giving control to the human. So the aspiration of this paper is to have an ethical inclusive AI to augment humans inside the vehicle to keep them safe in cars and roads. So autonomous vehicles can attain that promise to make our roads safe. Only when they are safe, only when people trust, then we can see them going on a larger scale. So this is the paper that is the research paper readout we had today. And I would like to ask if you have any questions, and we would like to take questions. So Suresh is here. Sudha is also here, and Susanna is here, who taught us inclusive AI. So we are open to questions.
Yash, can you share the actual URL link? I know this paper is published, so it's a print publication, but can you share?
Yes, I have all the links handy.
And you were walking over how a research paper, what is the structure of a research paper in the beginning. So can you tell people about citation? What does that mean, or formats of citation?
Yeah. So do you want me to show the paper again?
Yes.
Okay, I'll do that. So they say in research, we stand on the shoulders of giants. So we have all the references here that we have built on, that we have used, studied, drawn inspiration from, and then we have built on their work. So here there are different types of references here. So, so first of all, the format in which we do this, we call it the citation format. We call it the citation format. There are different citation formats such as APA, MLA. There is a Harvard format, IEEE format. There are a lot of tools available how we can create these citations. So in the citation by itself, the citation is all encompassing. That is, it will have all the details required for you to go and find that piece of information. It could be a research paper, it could be a website, it could be an article, a blog, it could be a book, it could be a class lecture. There are many forms of citations that are available. We can take them, and the format for each of them is different. It is based on what is the type of citation. Here, the different references that we have put, when we are building out based on them, here we put it in a small superscript here. So for example, this is Susanna's class on Inclusive AI Masterclass. It's 8. When we go to 8 here, we have the name, we have the course link. So basically, they'll be able to get that piece of information again by going to this link. Similarly, there are different papers here, and we have used Google Cloud Vision API. So we have given Google Cloud Vision API and the website. So this is how citations are there, and any research. So we need to keep reading research papers and then building out based on them. And we need to give credit from whom we have learned this, from whom we have taken this information, who was the first person who brought this out into the research field. So we build on it. So we saw we have an abstract, we have an introduction, we have the literature review, and we have the experiment methodology. Then we have the research findings, conclusion, call for collaboration, conclusion, and then we go to the references. So if there aren't any questions, can we, Sudha, can we go to Chinmay's presentation?
Yes. Yeah.
Yeah.
Thank you, Yash. Thank you very much.
Yeah, over to Chinmay. Sudha, should I be doing her bio again, or is that okay?
No, I think we did her bio and we don't have too much time. It'll be wonderful if
Okay.
she can present her paper.
Okay.
Yeah, just a second. It says the host disable screen sharing and writer share screen.
Can you try now?
Yeah, now I can. Hello, my name is Sudha Jamthe. I am in class 10 and I live in Bangalore, India. So my research is about averting human-elephant conflict using machine learning or elephant vocalizations. So Asian elephants play a pivotal role in shaping the habitat and directly influence forest composition. Asian elephants are an endangered species. There are only around 30,000 Asian elephants left in the wild, and their population is rapidly declining. In fact, over the past few decades, their population has declined by an estimated 50%. Currently, the greatest threat to Asian elephants is habitat loss, as this leads to encroaching and human-elephant conflict. So human-elephant conflict refers to the negative interactions between humans and elephants, such as in electrocutions, railway collisions, crop raiding, etc. So every year, human-elephant conflict can lead to attacks and violence and sometimes even casualties. Every year, more than 500 humans and 100 elephants are killed in India alone due to human-elephant conflict. So my research is about using machine learning and bioacoustics to detect elephants near human populations by the sounds of the vocalizations that they make. So early detection has been proven to help reduce instances of human-elephant conflict, which has negative consequences in the form of casualties and property loss. So in this project, I test my hypothesis that vocalizations or elephant vocalizations can be used to detect elephants earlier, as well as predict their current behavior. So whether they are aggressive and likely to raid the human habitat or calm and only passing by. I also this will also help response teams to take the appropriate action depending on the behavior of the elephant. So my project, it has two parts. One is the machine learning model, which determines if there are elephants nearby, as well as the current behavior and mood. The second is the AVOP device. This hosts the machine learning model and gives proximity alerts depending on the prediction of the machine learning model. So elephants commonly make 4 types of vocalizations. The first type is the trumpet. This is what we most commonly associate with elephants. And these are loud, conspicuous, high-frequency calls. They usually indicate anger or alarm. Then roars are long, noisy, high-frequency calls. They indicate aggression, distress, or play. Chirps are short, noisy, high-frequency calls, and they indicate a state of confusion or alarm. And finally, rumbles are long, low-frequency calls. These are actually the most commonly used by elephants. And some components are not inaudible to the human ear since they are infrasonic. They're used for communication within and between herds. So my machine learning model is able to identify and classify elephant vocalizations into these types and use this information to predict the mood or the behavior of the elephant. So, these are the steps I used to create the machine learning model. First was data collection and labeling, then was data augmentation, feature engineering, training, and finally validation, testing, and deployment. So previously, research of vocalizations made by elephants has been studied, but this has never been used to detect the presence and behavior of elephants. And the camera traps and video traps have been actually put up in many places. But I found that its effectiveness is limited in densely forested areas, which is the habitat of Asian elephants. So I use elephant vocalization into visual aids to enable more accurate detection in densely forested areas. I also use an electronic recording device, which helps me detect elephants that are producing vocalizations that are infrasonic, like the rumbles that I talked about before. I also try to predict the current behavior of elephants to determine whether it is likely to raid the village or just passing by. So I used data collected in Kaziranga National Park in Assam. It consisted of 147 recordings of elephants vocalizing in their natural habitat. This is the label distribution of a database and the number of files of each type that I worked with. So I use this data to create various iterations of machine learning models. Initially, I experimented with the standard in the field, which is MFCC coefficients with SVM models. Then I also experimented with deep learning networks, in particular CNN networks. I found that CNN models gave a better accuracy than SVM models, so I continued with that. And I created 7 iterations of CNN models. I put only the most important iterations here. I can show the rest later if you want. I tried experimenting with various inputs, data augmentation, and model architectures. So I tried chroma, RMSE, tried extracting features like chroma, RMSE, etc. So first I experimented with linear frequency spectrum, so just plotting the frequency against a time scale. I found that gave not so good accuracies, only around 20 to 30%. Then I try to just extract a bunch of features, chroma, RMSE, etc. I think I'll just show that. Yeah. Then I try to do all sorts of chroma, RMSE. All of them I tried at once, and that still gave me a low accuracy. So I just decided that I should try to narrow down on the inputs that I'm using. The first major increase in accuracy was when I used MFCC coefficients. So you can see the it was around 50% accuracy. Later, I used a two-level model or a flat model. So a flat model basically takes in surrounding sounds and classifies them into all categories. No vocalization, chirp, roar, rumble, trumpet, etc. all at once. Or on the other hand, a two-level model first tries to classify sounds at a high level and then further subclassify them. I found that it gave me much better accuracies. I also use modified MEL filter banks over the standard log MEL filter banks and a custom data pipeline, which I saw gave me my final accuracy. So this is an overview of my best performing machine learning model. So I used ensemble learning with a hierarchical two-level structure to classify vocalizations. This is a flow of my two-level model architecture. In the first level basically answers the question, is there elephant vocalization in the surrounding sounds or not? If there is an vocalization that is detected, it is then passed on to the second level, which further subclassifies the surrounding sound to determine what type of vocalization is being made. This is then analyzed to determine the presence of as well as type behavior of the elephant. I used modified MEL filter banks from each of the sound files to train my CNN model. These are the steps that I followed. The frequencies were first converted to the MEL scale, and then filter bank features were extracted. So usually the log of the filter banks are taken in, but I experimented with other transform features like cube root, square root, etc. I found that using the cube root gave me my best results. I found that this was because it increased the robustness of my sound features drastically. I also used a custom data pipeline to ensure uniform interleaving between classes. So these are my accuracies. The first level model, which like I said before, determines if there is an elephant vocalization or not, that gave me an accuracy of 96.88%. And the second level model gave me 100% accuracy for detecting low frequency vocalizations and 75% for high frequency vocalizations. So I then loaded these machine learning models on the Eliwog device. The Eliwog device is an IoT device which can be installed in the fringe areas within sanctuaries and villages. It consists of a microphone to record and store surrounding sounds, a Raspberry Pi to host these machine learning models, and alarm and LED indicators. So the Raspberry Pi sends alerts currently via Telegram when an elephant is detected nearby. This can inform the response team or the village about the location of the elephant as well as its current mood. All my CNN models were converted into TF-Lite models, which is an optimized form of these models to run in real time on the Raspberry Pi. This is a picture of my device and the parts. I found that the overall cost of this device was around 100 US dollars, or that's around 7,000 rupees. So in conclusion, I saw that CNN models trained on modified MEL filter banks as input gave me best results, and the CNN models maintain these accuracies when run in real time on the Eliwog device. So I would like to also integrate these machine learning models on visual machine learning models, collect and train the machine learning models with more data. So currently I'm using only around 147 recordings. I would like to use more recordings to increase my robustness and accuracy. I also want to use a unidirectional microphone to cancel out surrounding sound. Unidirectional microphone is basically a parabolic structure that is constructed around the face of the microphone so that it can collect sound only in one direction. This cancels out sound that could be arriving from behind the device, so basically from the village or the human habitat. I'm also trying to install a Eliwog device currently in a few sanctuaries for testing. Yeah, thank you.
Thank you, Chinmay. That was wonderful. And we are open to questions now.
Okay.
So Suresh is asking, How did you get interest in this?
So I mean, I actually in seventh, my whole family is interested in wildlife. So in a few years back, actually, me and my family went to Jim Corbett National Park for a safari, and over there, an elephant actually was disturbed by the sound of a jeep and it charged us. Like that was my first experience with human-elephant conflict, which our guide actually explained to us about human-elephant conflict. That was my first experience. After that, I actually volunteered with an NGO to study elephant behavior, and that was where I got this idea and the interest in it.
Yeah, and yeah. So the next question is, how did you learn about ML? You know a lot about the model, CNN models, and you knew under the hood of it, and you were able to code in TensorFlow. So how did you learn about ML?
It was actually self-learned over half a year. And when I was in ninth grade, first half of ninth grade, actually, I learned it. I was trying to work on another project actually, trying to detect the severity of COVID-19 using breath sounds. I had that idea. I knew that machine learning was something that could be used to do this, so I decided to learn it on my own. Because like it was peak COVID season that time actually, ninth grade last, that was like 2020. Peak COVID season. So I decided that I would learn this and try to do something about COVID-19.
So Sudha is asking, how did you get the training data for the elephant sounds?
Right, I was volunteering with NGO. They record elephant sounds. They're called elephant acoustics. They record elephant sounds in Kaziranga National Park. So they gave me some of their records.
Okay. Is this easily expandable to other animal sounds and languages?
Yeah, it would be, if I could get enough recordings, it would be easily expandable because most animals, obviously, the sounds that they make are quite correlated to the behavior that they show. So yeah, it would be easily expandable.
Yes. Any more questions for Chinmay? Okay, Raspberry Pi is becoming a game changer for novice ML enthusiasts. Can you tell us more about it?
Yeah, so a Raspberry Pi is basically a microcomputer. It is an ARM device. So it is basically a computer that is much cheaper and more affordable than a normal chip. It is because of that. It also gives accessible GPIO pins, so it can be easily used to control other devices like the LEDs and the relay systems and the alarm systems that I control. It also makes it easy to receive inputs. So it is basically like a tinkerer's device. It is like a computer for tinkerers. And since it's becoming more and more powerful with each generation, I'm using Raspberry Pi 4 here, and it actually has 4 GB RAM and it's quite fast. So it can be also be used to even host ML models. TensorFlow even actually developed an optimized form of their models, like what I use, TensorFlow Lite models, which can be easily deployed on these edge devices. Which is why and because of its increased computing power, it can also run this quite fast on real time. So it's getting more and more used.
And what were the challenges that you faced in building an IoT device?
So first I had to plan out the whole schematic, the circuits, and the how to host the CNN model on the Raspberry Pi. So I also had the first challenge was hosting the machine learning model on the Raspberry Pi. So I had to develop code for that and figure out how to host the models that I developed. then was actually figuring out how to, the machine learning model gives me some results. I had to figure out how to communicate those results to someone who's using this device. So like in the end, I used these an alarm system and LED, two LEDs. I actually have the device here. I actually have the device here. So this is an alarm system. It makes really loud noise. So that is to inform any villages nearby that an aggressive elephant is nearby. So you should probably clear the area.
Sorry, Chinmay, can you stop sharing your screen and show us the device much up close?
Yeah, sure.
Thank you.
I'll stop this. Right. So this is the device. This is an alarm system. 1 second, I'll just on it. This is an alarm system, and these are two LEDs. If there is no elephant detected, if there's a calm elephant detected, so basically an elephant is detected and is just passing by the human habitat, this green LED lights up. If it is showing signs of aggression, then the red LED lights up. And if the risk of aggression is quite high, if the risk of invading the village is quite high, then this alarm system starts ringing. So I could show that actually. Right. Can I share sound? I can play a sample file, have a sample file, and I can play to a speaker, and it will react to whatever I'm playing. So.
Yes.
Just a second. I'm opening it. Yeah. Okay, I'll just share it. Yeah. Can you see? I'm just play the sound, or I didn't share. Yeah. Can you see it? Okay, I'll just play the sound.
Yes.
I'll just and yeah, the green light glows. I'm not sure. The green light glows here. This is medium risk. So the red light glows as well. This is a trumpet. This shows actually quite high risk.
Can you show the device a little higher, Chinmaya? Okay, can you play that sound one more time, please?
One second.
Yeah.
Right. The speaker.
Yeah, we can see the green light now.
Yeah.
Oh, much. Yeah. Yeah. Just a second. The alarm is supposed to ring. Yeah. One second. The alarm did ring. I'm sorry about that.
Oh, that's all right.
Wait. I have a video though, if you want. I did take a video. I could share the link.
This is amazing.
Right. I just send the link in the chat. I also developed a Telegram bot, which basically sends messages via Telegram if an elephant is directly nearby along with the device. That is for the response team, because no one will be staying near the device all the time. So yeah, did you read that?
Yeah, it's really nice that you could explain all that and show your device and all of that. So the YouTube link that you have shared here, we will see it offline. Okay. So if there was any closing comments that you had to make or anything that you wanted to wrap up and show, you can show it now.
Yeah, that's it actually. Yeah, I have more. Yeah, these are just the features that I used. Like you can see here, just for chirps. I am actually plotting a chirp here. You can see that the last method, the method I'm currently using, has the most clearest features. Over here, the contrast is quite less. And the clearest contrast is here, which is what I meant by increasing the robustness of the sound effects.
And these are beautiful work. Awesome.
Thank you. And this is a plot of each type of vocalization that the elephant makes. So this usually indicates mild aggression. Sometimes you could even indicate play. So there is some risk, but not much. Rumbles is usually for communication. That means the elephant is just calm and just passing by most of the time. Trumpets and roars actually are what are dangerous signals. They are aggressive and they are quite likely to attack. So this is what the machine learning model detects. Yeah, thank you. That's all I had.
So Chinmay, you were showing us the audio screen only, right? When you were telling about features.
Oh, no, I was not. Oh, I'm sorry about that. Yeah, this is what I wanted to show.
Okay.
Like I plotted each type over here.
Okay.
Yeah, and the previous 3 methods that I experimented with. Like here, I'm plotting a chirp. Machine learning model in the end uses. You can see the contrast. These are the chirps. You can see that the contrast between the chirp and the background is the clearest here. While over here, this is the standard linear frequency spectrogram. These are the chirps, and it's not at all visible.
Nice. Wonderful work, Chinmay. Thanks for presenting it here.
No problem. Thank you. Thank you for the opportunity.
Sudha, shall we close today's session?
Yes. Thank you so much. Fantastic job.
Thank you, Chinmay.
Thanks
Very
everybody
good.
for joining Weeklywed. Yes, Suresh, you're telling something.
I was just very happy to see this kind of a work from a 10th grader. So it's so good.
Thank you.
Yeah. Keep us updated if Sudha or any of us from the team can help you out in any of your upcoming projects, please let us know.
Yeah, I would the next thing I also wanted to do was publish it. So if there's any way I could publish it, that would be great actually.
Wonderful.
Happy to help you with that, Chinmay. So this is good work, and you can build on it also. So it'll be best if we publish it in a nice, reputed, peer-reviewed journal. And what has been published, I think every publication asks for something new, but you have this work and you can build on it further also. So I'm happy to follow up, and Yash can also guide you.
Thank you. Yeah, sure. That'll be great.
Thank you, Sudha.
Yes.
Yeah, thank you, Chinmay, for coming here and presenting. Thank you, Sudha. Thank you, Suresh. Thank you, Susanna. Thanks, everybody who is there on the live stream here. We will catch next Weeklywed next Wednesday at 9 a.m. Pacific time. Bye.
Bye.